guys, welcome back to another video, and in this video we're going to be continuing on with our iOS development with UIKit tutorial series, and in this particular tutorial we are going to be taking a look at how we can put a UI collection view into our applications. Now, with a UI collection view, there are several ways that it can be done in terms of laying out your cells and all of that, but we are going to be using a flow layout today. Which will create a grid, and that is what you'll see most often. There are other ways to create different layouts, but we're not going to cover those today. We're only going to cover flow layout to kind of get you started. All right. So in this video, the example we're going to make is we're going to make an application that displays not all of them, but a good number of the device symbols available to you in SF Symbols. I have a constant called devices in my constants file, which is an array of strings, and those strings are the names of those device symbols that we're going to use. Again, it's not all of them, but it's a good number of them. All right. And the data specifically we're going to show in each of our cells is as follows. It's going to be the device symbol, so the image itself. And for that, we're going to use a UI image and UI image view. And we're going to color them green for just as kind of a random thing. And so I can see them a little bit better when we actually run it to confirm that it is working. And then we're also going to display the actual name of the symbol below it. All right, so let's go ahead and get started. First things first, we need to create our collection view. So inside of Xcode, let's go ahead and say var. I'm going to call it collection. And we're going to give it a type annotation of UICollectionView ! Now, why is this? Why am I using an exclamation point here instead of saying equals UICollectionView and using the initializer for it? Well, the reason for that is because a UICollectionView's initializer takes in two different parameters, a frame and the specific collection view layout that we want to use. If we do not specify the layout that we want to use in its initializer, then our app will crash, and our frame is required alongside it. So we need to be able to get the bounds of our view as its frame, and we cannot do that if we just say var collection equals UI collection view, where we normally create our objects. We could use an initializer in our UI view controller subclass, but that still begs the question: how would we get the view and its bounds? Well, we can't do that in a initializer either. So we're going to do it in a separate method that is called by our viewDidLoad. All right. So we have to specify this as potentially optional here. All right. Now, if we go into configure, you can see we have configure devices collection and configure constraints. That's fine. Inside of our configure devices collection, let's first create the layout that we're going to need. So let layout equals UI collection view flow layout. This the UI collection view flow layout does not require any parameters in its initializer, so we can just keep it as is. But there's one property we should set here, and that is the item size. Because if we don't set the specific item size, it's going to try to size the cells on its own, and it may or may not be what you want to happen. But in this case, we're going to specify a concrete size so we know what we're working with. So we'll say layout dot item size, and this is going to be a CG size. So CG size with a width of, let's say, 125, and a height of 150. Like that. So there we go. Now let's actually initialize our UI collection view. So collection dot, or not dot, collection equals UI collection view with a frame of view.bounds and a collection view layout of layout, like that. And that is our collection view object created. So and besides this, we don't need to call any like set collection view layout or anything like that, because our initializer has that layout already. And because we have specified the frame of our collection view, we don't need to worry about auto layout. So we can leave translates auto resizing mask into constraints alone, and all of that. What we do need to do, however, is add our collection view to the view itself. So we can say view add subview, and we'll add collection to that. All right. And so that's all for the layout. But we do need to create a delegate and data source, much like a table view. So above where we are adding our collection view as a subview to the view, we can say collection dot delegate equals self, and collection dot data source equals self, like that. Perfect. Now that we have our delegate and data source specified, we're going to get errors. And these errors are telling us that our main view controller here doesn't conform to UI collection view delegate or UI collection view data source. So I have an extension prepared where we can add that those protocol conformances. So in our navigator, I'm going to go into our extension here. All right. So here we can add the protocol conformances for UI collection view delegate and UI collection view data source. Now there are a few different kinds of data source objects here. We can do normal UI collection view data source, UI collection view data source prefetching. We can do UI collection view diffable data source and that kind of thing. But we'll use the normal data source object or data source UI collection view data source protocol. We will take a look at diffable data source in another video because that is a more modern way of creating collection views. We'll also take a look at the diffable data source for the table views because, again, that is a modern way of creating our table views. But again, that's for another video. So UI collection view data source. And these methods that we need to implement here are very similar to the methods that we had to implement for UITableView delegate and UITableView data source. Much like UITableView delegate, every method in the UICollectionView delegate are optional, so you don't need to implement any of the methods there. But if you need to do something specific that isn't in the data source, then you will need to implement some kind of method from the delegate. But the only methods that we need to implement are from our data source. And the first one is how many items there are. Optionally, how many sections there are, which we're going to do. And then we need to also override the, cell for item at index path, which is the method used for defining our cells and returning them to be displayed. The mechanism for dequeuing reusable cells in a collection view works exactly the same as it does for UITableView, except the signature is different, and we'll take a look at that when we get to it. So let's go ahead and first say number of, let's see, it should be number of items in section. Here, for our placeholder, we'll say return devices.count. All right, but we're not done. The second method that we need to implement, well, not need to implement, but I'm going to implement, is number of sections. And we will return 1 because we only have one section. If you wanted to split the symbols into sections, you could do that. Like, for example, any and all symbols that have to do with the iPhone or the Mac or the iPad or peripherals or that kind of thing. If you wanted to split them into sections like that, you could. But we're not going to in this particular example. We just want one section. And then finally, we want cell for item at. And then here is where we're going to define our cells. Like I said, DQ reusable cell is going to be a slightly different signature with the collection view than it was with the table view. But we need to instantiate our cell object the exact same way using a guard statement. Otherwise, it will be an optional UI collection view cell. So we can say guard let cell equals collection view dot DQ. We want DQ DQ, there we go, DQ reusable cell. And the first parameter isn't like isn't a specific like nib or cell type or anything like that. For collection view cells, we don't need to specify that. The first parameter is going to be the reuse identifier. Now, although now that I think about it, I don't think we, if we did, wait, no, yeah, we did have to do this. We did have to specify the cell type. In this, we don't have to. First parameter is the reuse identifier. We don't have a reuse identifier yet because we haven't created our cell yet. So we'll say device cell dot, we'll call it ID. And then the second parameter is for. This is going to be the index path of the specific cell. So we'll say index path. Like that. As question mark device cell else return a blank UI collection view cell. Like that. Pretty simple. On this cell, we will have a set method like we did for our table view cell. So we'll say cell.set, and we just want to pass it the device name. So device name is going to be devices at the specific index path.row. Like that. All right. And then finally, we will return our cell. And that's it. Now, of course, we don't have device cell. We don't have an ID. So let's go ahead and create that cell. In our navigator, project navigator, we will say new file from template. I'm going to say Cocoa Touch class, and we'll say device cell, and we want this to be a subclass of UICollectionView cell. And we're going to get rid of the ending here. And so it's just device cell. And there we go. So here we are in device cell. Now in here, one of the first things we need to do is override the initializer for that takes a frame. So override init frame with a cgrect as its type, and then we call super.init frame like that. Then we need our required initializer. So required init coder ns coder, and then fatal error not supported. All right. Then up at the top, we'll need a static let ID equals device underscore cell. So now we have a reuse identifier for our cell. And then we need our set method. So we'll say func set device name string, like that. And one thing that we should keep in mind is that much like UITableView cells, we can use SwiftUI for our cell content, but in this example, we're not going to do that because I want to show you both ways. In this video, we're going to show you how you can do it the traditional way, and then in another video, I'll show you the way that we can do it with SwiftUI, which is the more modern way of doing it, and in fact is the way that I personally would recommend doing it, as well as using a diffable data source. But again, that will be in a separate video. All right, so in here, what we want to do is we want to create two user interface components. And these components are going to be a UI image view for our symbol, and then a UI label for the name of the symbol. So var device image equals UI image view, and give this an image of UI image with a system name of device name, like that. Device name, like that. Okay. And all right, we're good. Second is our label. So var device name label equals UI label, like that. Now we're going to configure both of these views. So we'll say device image dot content mode equals scale aspect fit device image dot tint color device image dot tint color equals dot system green. This can be any color you want. I'm using green. And then we'll say device image dot translate auto resizing mask into constraints equals false. And then we'll add it to our the content view of our cell. So the content view of a UICollectionView cell is where all of the content of the cell is supposed to live. So we'll say content view dot add subview, and this will be device image. All right. Next is configuring our label. So we'll say device name label dot text equals device name. Device name label dot text color is going to also be system green. Device name dot name label adjust font size to fit width we'll set that to true. And then we'll say device name device name label dot translates auto resizing mask into constraints equals false. And then we'll say content view add subview device name label. All right, so we've configured our device image and we've configured our device name label. Now we need to actually set the constraints for these particular views. So it's exactly the same way of doing constraints that we have done forever now. So we'll say ns layout constraint dot activate All right, I want to make sure that everything's good to go here. All right, so here we'll say device image dot width anchor dot constraint is going to be equal to constant of 125, and then the device image dot height anchor dot constraint is going to be equal to constant of 125 as well. So it's a nice even square. And then we'll set the device image dot top anchor dot constraint is going to be equal to content view dot top anchor, and then for the X position it'll be device image dot center X anchor dot constraint is equal to content view dot center X anchor. Because if you recall, our views have, and when they're being constrained, have to have a X, Y, width, and height value. Otherwise, auto layout is going to get confused and you'll get not so great results. All right. So the center X anchor and top anchor, that sets the X and Y position of our image, even though the image is as wide as the content view is supposed to be. Right? But we need to make sure that the image is positioned flush with the top anchor of our content view, because we need to make sure that there's room for our text in our 150 high cell. All right? Now, if 150 isn't enough, that's fine. We can adjust it as needed, but this is, just to make sure that we have enough room for our label here. Now let's constrain our label. So device name label dot leading anchor dot constraint is going to be equal to content view dot leading anchor with a constant of 5. Then we'll have we'll go ahead and copy our leading anchor here. But instead of leading anchor, it'll be trailing anchor. So trailing anchor dot constraint is equal to content view dot trailing anchor with a constant of -5. And then finally, the label device name label dot bottom anchor dot constraint is going to be equal to content view dot bottom anchor with a constant of -5. There we go. All right. So with that, we should be okay. Now, again, we can adjust the item size if needed. In fact, we probably will end up having to, but that's fine. It's not the hugest of deals. All right, so now it might be a good idea if you want to put the top anchor, just constrain the top anchor. But we're going to leave it for now. We'll save this. And that is our cell. We have some kind of issue, so we'll take a look at the issue navigator. All right. Okay, there we go. That should hopefully fix the issue. All right, there's our device cell. That's done. All right, so now there is something. It's trying to say that we don't have our protocol conformance, but we should. Okay, we do. We just had to build to make sure that Xcode recognized the changes here. All right, so let's go ahead and change the height. Let's go ahead and change the height of our cell. From 100 and 150. To, let's say, 175, just so we have an extra little bit of space. And so with that, the last thing we need to do is we need to actually register a cell with our collection view. So let's go ahead and do that. Collection.register cell class, and we want device cell.self. And then we need to give it our reuse identifier, so device cell.id, and that's it. Let's go ahead and run our code now. We have a successful build. And here is our collection view. So we have keyboard, keyboard fill, printer, all kinds of different cells here. All right. So that pretty much does it for this video, guys, on how we can create a UI collection view and place it into our user interface. Thank you all so very much for watching, and we'll see you in the next one.